Hey guys, so we are going to take a look at the heart. There are notes that go along with this video on aandbonline.com in the module that this video is going to be posted in. Unfortunately, I'm going to be jumping all over the place based on what's easiest to teach when, but for the full list of structures, what's on your notes, unless I specifically say something isn't going to be covered, will kind of be like your test bank. Okay, so I'll be sure to upload the notes alongside the video. We're going to start off with the heart chambers and septa. So that's kind of a easy place to start. So we have two ventricles. Now this app is kind of breaking it up into odd ways, but basically I'm going to try to remove some of this stuff so we can see the different chambers we're going to be talking about. So there are two receiving chambers. We have the right atrium here, and then the left atrium in there. They're called receiving chambers because they're receiving blood from the two circuits of your circulatory system, the systemic circuit and the pulmonary circuit. So right here, this atrium, left atrium, is receiving blood from these four pulmonary veins, which you can't see particularly well. You can see two there, 1, 2, 1, 2. So that atrium is receiving blood from the pulmonary veins, bringing blood back from the lungs filled with oxygen. This right atrium is receiving blood from the inferior vena cava and the superior vena cava. These are the two main veins that bring blood back into your heart, specifically into the right atrium. So the pulmonary veins bring blood back to your left atrium. The vena cava bring blood back to your right atrium. This blood is coming from systemic circulation. So all the blood below your heart is returning back to this right atrium through the inferior vena cava, and all the blood above your heart is returning through this superior vena cava. So head, arms, superior trunk coming through here, abdomen, legs returning here. Venous blood from those places is returning here. Those are the atria. After the atria, the blood moves through these two atrioventricular valves right here. So there's one, and there's the other, into the two ventricles. So we have the left ventricle here and the right ventricle there. These are the discharging chambers, the chambers that pump blood out. Typically, we see the muscle of the left atrium being significantly larger. For whatever reason in this app, it isn't necessarily the case. But typically we would expect the muscle wall over here to be larger. So you're just going to have to know it based on direction. So this is the left side of the body. So that's the left ventricle. And then this is the right side. So that's the right ventricle. All right, so let's talk valves now, and then we'll talk septa. So the valves in between the atria, the top receiving chambers, and the ventricles are located right here. You can see this one here and this one there. They break them out into the individual leaflets. We're not going to do that. So basically, this valve right here is between the left atrium and left ventricle. So it's the left AV valve. This valve over here, there are other names for these, mitral, tricuspid, but we're just going to keep it the most modern, which is most common and most modern, which is left AV on this side, and then right here is the right AV valve. You can kind of see a better view if I hide some of these bones, maybe. You can see a top view of the right AV valve right there. Okay. All right, so those are the two AV valves. Now we're going to have to look a little harder here for the aortic and pulmonary semilunar valves. So that right there is the pulmonary semilunar valve. That's the term I'd prefer. If you say pulmonary valve, I won't take points off, I guess. But so that's the pulmonary semilunar valve, and that's a valve inside of the pulmonary trunk. So you can see the valve right there really easily if I remove the pulmonary trunk. All right, here's the aorta. We're going to find a similar valve inside the aorta. There it is. Can you see it? right there, that is the aortic semilunar valve. If we remove the ascending aorta, you can see that from a top-down view. So here's the aortic semilunar valve, here's the pulmonary semilunar valve. So those are the 4 heart valves and the 4 heart chambers. Now we have some septa. Sorry. So we have um, we have an interatrial septum, which is going to be the hardest to really see because there's so much here. There's so much structures and vessels in front. But there's this wall right there is in between the 2 atria. It's kind of nice in person because you can stick your fingers, your thumb in here and your index finger in here and touch them, but back behind this stuff, there's a thin wall that separates these 2 chambers. It's called the interatrial septum. Can't really get a good view. I mean, that's an okay view right there, but I don't know if I would tag that. So anyway, that's interatrial. Interventricular is very easy to see. Right here, this is the interventricular septum. It's the septum that divides the 2 ventricles. And then also fairly easy to see is the atrioventricular septum, the septum in between the atria and the ventricles. And when we talk about the heart in lecture, we'll talk about how this is, not only is this a physical septum, but it's also an electrical septum. It prevents electrical signals from mixing at the wrong time between the atria and the ventricles, so it's pretty cool. And that's actually what these valves are set in. They're set inside this atrioventricular septum. Okay, I drew it on the front here, but really it goes all the way around, right? It's the septum all the way around the atria and the ventricles that divides the atria from the ventricles. Okay, that's atrioventricular septum. So we talked about heart chambers, we talked about septa, we talked about heart valves. We did not talk about auricles. Now, auricles I think we talked about when we talked about strokes, because it's a place that blood has a tendency to pool and coagulate and form clots, especially if you have atrial fibrillation. So let me remove those. You see these 2 structures on top of the atria right here? These are called auricles. Some hearts are more pronounced than others. This is pretty not pronounced, but sometimes they look like little ears because they kind of hang down and fold over like a dog's might fold down. So you can kind of sort of start to see that, not really, but anyway, so here's the right auricle and the left auricle. Those sit on top of the atria. And then lastly, before we get into like the coronary vessels and the great vessels of the heart and the pathway of blood flow, we're just going to talk about some of the different types of myocardium. So myocardium is this heart muscle. There's 3 layers to the heart wall, which we'll cover in lecture, but there's an epicardium on the outside, an endocardium on the inside, and then myocardium in between. So myocardium has different names in different places. For example, right there, if you look inside the ventricles, you see this very coarse spiderwebby type of muscle, all of these structures in here. Okay, that's called trabeculae carnae. And then you have bigger muscles here that are connected to the valves, specifically these little tendons here, which are called chordae tendineae. Chordae tendineae. That is, those are in your notes. That chordae tendineae is anchored down to these muscles here called papillary muscles. So that's the only spot papillary muscles are found. They're found where there's chordae tendineae. There's some on the right there. That's what the AV valves are anchored to, the papillary muscles. So trabeculae carnae and papillary muscles. If we open up the atria, man, why am I yawning so much? It's so hot in this room. I'm sorry, guys. That's why. I could edit it out, I guess. Anyway, if we look at the walls of, that's not too great looking, honestly. Oh boy. Nope, I was worried that whole thing would be hidden. Okay. Well, within the atria, so this here is called pectinate. The walls of the atria, which are kind of tough to see, like here would be the wall of the atria, wall of the atrium, as well in here. The lining of the atria is called pectinate. The lining of the ventricles is called trabeculae carnae, and then these bigger, more pronounced muscles that the chordae tendineae is attached to, those are called papillary muscles. All right, so I'm going to reset it because now we're going to look at the great vessels. We've already named several of them in passing while talking about the valves, but let's just go through it officially. So right here, coming out of the right atrium, we have the pulmonary trunk. Pulmonary trunk splits into the right and left pulmonary arteries. These are the only arteries that are colored blue typically because they're calling that right pulmonary trunk and left pulmonary trunk. I typically don't see that. Typically, once it splits, we call it the pulmonary arteries. For the purposes of our test, we'll just have the one pulmonary trunk, the left pulmonary artery, and the right pulmonary artery. Anyway, that's carrying hypooxygenated blood that's already made its trip around the body. It's being pumped to the lungs through the pulmonary trunk. Then it comes back through these structures, 4 pulmonary veins. It doesn't look like they've labeled them, but anyway, so these are named based on location. So this would be the right superior pulmonary vein and the right inferior pulmonary vein. This would be the left superior pulmonary vein and the left inferior. So this would be the left superior. This would be the left inferior. Okay. Again, right superior pulmonary vein, right inferior pulmonary vein. Okay. Then it comes back into the left atrium, goes to the left ventricle. The left ventricle pumps all of its blood out into the aorta. They're breaking it down a lot to aortic bulb, ascending aorta, aortic arch, descending or thoracic, and then descending aorta. For the purposes of our test, anything tagged in here, you can just put aorta. We're keeping it pretty basic. Okay, so we talked about the pulmonary trunk, the pulmonary arteries, the pulmonary veins, and the aorta. After all the blood goes through the aorta, goes out to systemic circulation, eventually it makes its way back and re-enters the heart through either the inferior vena cava or the superior vena cava. And those are all the major vessels of the heart. Just quick recap. Aorta, pulmonary trunk, pulmonary arteries, 4 of them. I'm sorry, 2 of them. Left pulmonary artery, right pulmonary artery. 2 vena cava and 4 pulmonary veins. The only thing I forgot to mention is the conus arteriosus right there. This is a smooth muscle band around the base of the pulmonary trunk that can kind of constrict or dilate here to affect blood flow to the lungs. So that's called the conus arteriosus. So lastly, we have we just have the coronary vessels. Coronary vessels. Okay, so let's start off with, we're gonna have to move some stuff. So let's move some of these auricles. There we go. So the coronary vessels, they all come off the aorta. They're actually the first vessels to come off the aorta. And what is unique about these arteries is that they actually supply the heart with oxygen. All of the great vessels, their job is to supply the body with oxygenated blood, return hypooxygenated blood, or bring hypooxygenated blood to the lungs for oxygenation. They're moving large volumes of blood around for the body, and the heart is the pump. It's actually 2 pumps right next to each other, but we'll cover that in lecture. The heart is the pump. Anyway, the coronary vessels are vessels that come off the aorta to supply the heart with oxygenated blood specifically, so nutrients and oxygen. And they're right here. This is the left coronary artery and the right coronary artery. These 2 arteries give rise to all of the arteries that supply the blood with, or supply the heart with blood. And if the phrase, had a coronary, that's referring to like an infarction of one of these vessels. This is where heart attacks would occur. Ischemic events, clots, lodge themselves in one of these arteries and occlude blood supply. And that's a heart attack. Um, so let's run through these. So we have two branches coming off the left coronary artery, which I have highlighted here. We have the circumflex branch. Let's make sure that they call it the circumflex branch. Yeah, we have the circumflex branch, and they have this marginal branch of the left coronary artery. I very rarely see it like this, which is why my notes don't reflect this. So typically I see the left coronary artery with the anterior interventricular and circumflex branch, and this is coming off the circumflex branch, which I guess is technically what they're drawing here. It's just they've highlighted it in a different way. So what we're going to do is we're going to name only two structures coming off of the left coronary artery, and they are the anterior interventricular artery, or you can say anterior interventricular branch of left coronary artery, and the circumflex branch of the left coronary artery. Circumflex branch is fine. Anterior interventricular branch is fine. That's all you have to write. Okay, so that's it for the left coronary artery. Remember, this is the left side of the heart, right? This would be this, that's an arrow, believe it or not. Because over here would be the subject's left hand, and anatomical position is based on the subject. So this is the left side of the heart, which makes this the left coronary artery. This is the circumflex branch, and this is the anterior interventricular branch. Okay, so let's go over to the right coronary artery. There's really only one, there's really only one thing on here that I need you to know, and that is let's see if we can get to it. I need to hide some vertebrae. Oh, but then we got the aorta there. Right here, the posterior interventricular branch. So the anterior interventricular branch comes off of the left coronary artery. The posterior interventricular branch comes off the right coronary artery. Okay, so right coronary artery, posterior interventricular branch. You can see it a little bit better. Okay, so then we have a couple veins. Don't worry about the anterior and posterior interventricular vein because I don't see them. I mean, they're not here. They don't have veins on the heart. So you can cross it. Oh, maybe there's a separate. Yes. Oh boy, but that's kind of a mess. Yeah, I'm going to stick with my original. Don't worry about the posterior and anterior interventricular branches. I do want you to know where the coronary sinus is, which is what I'm about to show you here. We hide some stuff and add veins back in. Oh boy. Look at that inferior vena cava. How cool is that? Okay, so the coronary sinus is right here, and it's this large kind of, it actually usually looks much larger than that even, sort of bulbous area back behind the right ventricle, kind of at the base of the inferior vena cava as well. It's called the coronary sinus, and those are all in your notes. Don't worry about posterior interventricular vein and the anterior interventricular vein. And guys, that's it technically for the heart. I just want to run through the pathway that blood takes through the heart. That's typically something I do in lecture, but since we're here and this is so nice. So obviously the pathway, the entrance point into the heart is going to depend what part of circulation you're in. So let's pretend, if any of you guys have seen the magic school bus, that we're in a school bus, we've shrunk down to the size of a red blood cell, and we've been put into right here. Okay, we got injected into the jugular. That'd be kind of rough for the patient, but so anyway, we would travel down into the superior vena cava. If we were injected down in the leg, we'd go up through the inferior vena cava. But if it's systemic circulation, a vein and systemic circulation, we're going to enter the heart through one of the vena cava. Okay, and then from the vena cava, let's say it's this one here, superior, you go into the right atrium. That's the first chamber we would enter. Then we would pass through the right AV valve into Whoa, I didn't want to do that. Oh boy, it's kind of anticlimactic now. I got to reset everything. Okay, this is what I wanted to get rid of. So we would move through the right AV valve, right there, into the right ventricle. So now we're in the right ventricle right here. From the right ventricle, we're going to go through the pulmonary valve, pulmonary semilunar valve right here. The ventricle contracts and pushes us through that valve into the pulmonary trunk. From the pulmonary trunk, we'd go into one of the pulmonary arteries, left or right. We would go to the lungs. We'd be picking up lots of oxygen with the red blood cells, and then we would come back through one of the pulmonary veins. Oh no. Okay, we're all right. We'd come back into one of the pulmonary veins right here. So here are left pulmonary veins. It's weird because they're red, but they are in fact veins, because a vein is a vessel that carries blood towards the heart. An artery is a vessel that takes blood away from the heart. So these are veins, even though they're red. They're red to show that they're oxygenated. It's the only vein that carries oxygenated blood. There are only 4. So anyway, so these are the left pulmonary veins. The right are over here. Let's see if we can get over there. There they are. You can sort of see them through the ribs. Okay, but let's say we go back through these ones. So that brings us into the left atria. So in there's the left atria. From the left atria, we're going to go through the left AV valve, which is this valve right there. And then we're into the left ventricle. This large chamber here is the left ventricle. The left ventricle is what pumps blood out to our system, into systemic circulation. And it does so by pumping through this valve right here called the aortic semilunar valve. When it contracts, it opens that valve, forcing blood into the aorta. And from the aorta, you go out to circulation. Actually, when that valve opens, the aortic valve opens right there, that's when you feel your pulse. Because the pressure in the entire systemic circuit goes up about 40 millimeters mercury or so, depending on what your pulse pressure is, when that valve opens. And then you're out into circulation. So that's the pathway through the heart. A vena cava, a right atrium, right AV valve, right ventricle, pulmonary semilunar valve, pulmonary trunk, pulmonary artery, lungs, pulmonary veins, left atria, left AV valve, left ventricle, aortic semilunar valve, aorta, and once you're in the aorta, you're into circulation. So that's the pathway that blood takes through the heart. In lecture, we're going to go into that in a lot more detail, and we're going to look at cardiac cycle, and we're going to look at the events of cardiac cycle and see that, yes, that might be the path that an individual cell would take through the heart, but that isn't necessarily the order of contraction in the heart. It's very different. The electrical events are very complicated and coordinated. So we'll talk about all that in lecture. For now, that's just a short 30-minute video or so on the heart. Hope you enjoy. I'll be posting one about the lungs here shortly. Thanks.